What is electricity? We all are quite familiar with the electricity and its working principle by now. But did you ever think what electricity is? How will you explain the flow of current? Yes, it is a big question for so many people. But we can be sure that the answer is not so complex. If you understand a few things properly, then you will be able to know what electricity is and how does it work. Because we all should know this property to understand different machines used by us in our daily lives, we cannot live without electricity these days, and that is why it is quite necessary to understand the whole working principle of it. First of all, you should understand what an atom is if you want to know the internal details regarding electricity. An atom consists of three different elements or particles which are differently charged. One is the neutral neutron. The second one is proton, which is positively charged. And the last one is an electron, which is negatively charged. Proton and neutron stay inside the nucleus, which is actually at the core of the atom. On the other hand, electrons move along the orbit just outside the nucleus. So it is clear that proton and neutron don't stay together because of the high charge in both of them. Moreover, electrons stay put in its place because of the attraction between itself and the positively charged proton. All of these particles are somehow responsible for electricity generation. There are so many atomic models, but this is the basic structure of an atom in any material. Among all of these particles, the electron is the carrier for charge and generally responsible for electricity transportation. In an atom, electrons and protons have the same charge with different type, and that is why they don't overlap with each other at any point in time. The electrostatic force is another element of electricity which you have to know if you want to go deep into the principle. It is a type of force which is there between two charges separated by a particular distance. According to Coulomb's law, the same type of charges repel each other, and the opposite type of charges attract each other. This is the main crux of the whole idea of electricity. The magnitude of the force on the two different charges depends on the factor that how far the charges are placed. If the charges can get close, the force increases. According to the electrostatic force, the electrons always repel other electrons in the path and also attract towards the proton because of opposite charges present in it. That is the main reason why atoms are always held together. But if you want to generate electricity, then these electrons must flow. Now, if we are thinking about the flow of electrons, then we will have to make it a charge carrier. If we want the electron to be a charge carrier, then we must use the proper electrostatic force to do so, that the electron can be ejected from the orbit. Then only it will become a free electron. Most of the time, metals are more likely to eject free electrons, and that is why they are good conductors. On the other hand, there are some materials which cannot eject electrons so easily, and they are the insulators. Whenever we make a cable for electricity conduction, proper insulation is given to it so that safety can be maintained. Now, electricity is of two types. The first one is static electricity, and the other one is current electricity. Static electricity is created whenever opposite charges are there in an insulator. Static means at rest, and that is why this type of electricity stays in the same place until the charges are balanced again. If the charges are balanced, then the static discharge takes place. Sometimes this type of discharge happens in open air, which can create an electric shock when it releases the energy, and can be proved to be quite harmful sometimes. Static discharge can explain the phenomena of lightning very well. In this process, the clouds have enough charge concerning the other clouds, and when the charges try to get equalized, there is a huge quantity of charges traveling in the air, and this effect is quite visible all the time. Current electricity is all about the flow of electricity through some specific systems. You will need circuits to generate this type of electricity, and it is the main phenomena we always need in our lives. When different charges can flow constantly, current electricity is generated. This type of electricity is dynamic, and the charges move all the time. This is the main type of electricity, which is our concern here to explain this principle. You have to create a closed circuit if you want a constant flow of electricity, and the circuit should be of some conductors. If you put some kind of insulating gaps, then the circuit preparation will be incomplete, and the electron flow will not be successful. That is why most of the time this type of circuit is made with metal wires and other conductive materials. But for safety purpose, the insulating materials are used to wrap the cables properly so that no one can get hurt by an electric shock. These are the main ways by which electrons flow from one place to another and the electricity is generated. But there are some other factors as well which are responsible to make it happen. The factors are electric field, potential energy, etc. Now we're going to discuss the electric fields in detail. An electric field is a tool which is used to create a collision between the electrons to generate electricity. If you want to know how electricity starts its journey and continues its flow, then you have to understand the different electric fields. It is the actual force between the charges to attract or repel each other. Generally, the direction of the electric field is always towards the path where the positive charges move. If you want to construct an electric field, then you have to put both types of charges together. You will get to know the direction of the charge by following the path of the positive test charge. If you want a constant flow of electricity, you have to generate a uniform electric field. Then only will you be able to generate the charge throughout the time without any interruption. Now, potential energy is all about the energy present inside a particular object so that it can work on any other object. There are so many forms of electricity, among which kinetic and potential energy are the most important ones. Kinetic energy is present in an object when it is moving. On the other hand, potential energy is the energy stored in an object when it stays at rest. Potential energy can be defined as the ability of the object to work if we set them into some motion. Most of the time, we can control this energy, and if the object starts moving, the potential energy is converted into kinetic energy. If you put positive and negative charges, then the flow of electricity will always be from the positive charge towards the negative charge. Because the positive charges have high potential energy in it and the negative charges have low potential energy in it. And according to several principles, the current always flows from high potential energy to the low potential energy. These are the basic factors which affect the flow of electricity in our daily lives. This is the whole idea of electricity and how it is generated by different charges. Now, if we have to summarize it in short, then electricity is nothing but the flow of charges. These charges are carried by the free electrons present in an atom of a particular material. Most of the time, the electron present in the last orbit generates the electricity because it is more likely to get ejected if the system is given proper electric force. If you make a full circuit, then you will be able to convert the potential energy present in an object to the kinetic energy, which can generate the current electricity successfully. Electricity always flows from the high potential energy to the lower potential energy area. That is why if you keep oppositely charged test particles in a particular area, the current flow will be towards the negatively charged particles from the positively charged particle. An electric field is necessary to put this type of force to the particles so that the electricity generation can become uniform and consistent. So we have discussed the electricity and its generation procedure. If you have understood all the factors mentioned above, then it is quite certain that from now on you will be sure about the electricity generation questions in your mind. There are so many other factors involved in it, but those are quite complex. If you want to know them, you must clear your doubts about these factors first.